Hi guys, welcome back to the channel. So today we are going to be solving today's state code question, which is open the lock. So we are given a lock which will consist of four circular wheels. That means it will have four circular wheels, and then it can be numbered from 0 to 9. And then we need to rotate this particular lock such that it will unlock. And there is one more condition, that the lock will always start from 0 0 0 and then 0, and then the string represent the state of four wheels. That means, suppose let's say here it is 0, that means first wheel has 0, and then if it is 1 here, then the second wheel has 1, and then if it is 2 here, then the third wheel has 2, and then if it is 3, then the fourth wheel has 3. So it represents the state of this particular whole wheels of four wheels. And then we need to find the number of minimum number of turns required to open this particular lock. And then if we get this particular target from the starting point, then we are going to say this is the target we want, and then we are going to return the minimum number of turns to required to open this particular lock. And there is one more thing which is mentioned in the question, that there are dead ends. That means, suppose let's say you turn to some dead end. That means, suppose here it is given that 0 to 01. In any time we come across with 0 to 01, then we cannot move to next state. That means, if we cannot turn 2 to 3 from this particular state, so this is going to be dead end. We cannot move this particular lock after getting the dead end. So whenever we get the dead end, we'll stop there itself without moving to further. Suppose let's say this is 0 0 0 0, and then the target one is 0 2 and then 0 2. Now if we see this, we are going to use 0 0 and then 0 0. We are going to turn it to 1 and then 2, and then again 102 and then 0202. But there is one condition, that 0102 is a dead end. That means we came across this particular dead end. So we cannot move from 0102 to 0202. So this will not be a valid condition. That's why we are going to use this particular transition where we are going to get 02 and then 02. So to solve this particular solution, we are going to use a BFS search. Why? Because suppose let's say we are given 0 0 0 and then again 0. So we will get all the possible cases which we can do from this particular slot. Suppose let's say I'll change the wheel state from 0 0 0 0 0 2. I'll just change the state to 1, or I'll just change the state to 9. And then there can be one more possibility, that I'll pick the next digit, and then I can change to 1 or I can change to 9. And then for another digit also we can consider 1 9, and then another digit also we can consider 1 9. So those are going to be our neighbors, and then the current node is going to be our current node. And then whenever we move to the next particular state, we are going to check whether this particular state is already been present in our BFS or not. If it is present in this in our queue, then we are not going to use this particular transition. Why? Because it is already taken in the queue. So that particular state is going to give us a result. We are not going to consider this. And then suppose let's say we come across any node which is present in this particular dead end, then we are going to say that we will not be considering that particular node which is present in this BFS. So let us see the code for this. So we are going to take the dead ends which will represent all the dead ends which is present in this particular dead end, and then we are going to take visited, which will store the visited nodes, visited state of four wheels. And then we are going to call, if it contains zero state, then we are going to return -1, and then we'll add into our queue the starting state, which is going to be 0 0 0 0, and then we'll insert. And then after that we are going to count the number of moves which are required to start from here and then to reach this particular target. And then we are going to calculate, we are going to get the size of this particular queue. And then for this particular queue we are going to traverse a total level. Suppose let's say we have four nodes which is present in this particular queue. So these four nodes are connected with other nodes, and then those nodes needs to be completed in this particular move only. Why? Because we are calculating the number of moves which required from one node to another node. So that's why we are taking the size, and then we are getting the source, and then if the source is equal to target, then we got the target. That's why we are going to return number of moves, and then we are going to get the adjacent nodes from this particular source. And then for each particular adjacent node, we are going to check whether this particular node is already visited. If it is visited, then we do not need to consider it again. Or suppose, let's say, if this particular node is dead end, then we are not going to consider. Otherwise, we are going to insert into our visited array, and then we are going to push into our queue. And then we are going to increment the moves. Why? Because this level has been completed, we move to the next level. And then suppose, let's say, if we did not find the target, then we are going to return -1. And then if we come to the get adjacent nodes from this particular source node, so we are going to have 4 digits, the 4 states. So that's why we are going to pick one out of one out of the these particular states. And then we are going to change it to -1. Like, we'll move to the left or right, and then +1 we'll move to the right or left. And then based upon that, we are going to calculate the current I, and then we are going to push into our neighbor elements, and then we are going to return the neighbor. For these neighbors, we are going to do these operations, and then we are going to return the answer. Yeah, that's all for this video. Thanks for watching.